Yeah, can you see the VM? Yeah, in the screen share, can you see the VM? The VMware Ubuntu and all?
Yeah.
Yeah, okay. So yeah, today we are discussing about user management and process management. And the process management will go very deep, actually. Yeah, if you have any questions, it's fine. You can ask in the middle of the session or end in the end, you can ask. Okay. So yeah, let's start. So my IP is this is a bridge mode I'm using. So as I told, we will discuss what is the bridge mode of networking. So let me connect to the VM. So I'm using Putty. You can use MobileX or any other tool, whatever is convenient for you. Okay. So yeah, let's go back to that. Yeah, we are working on the user groups. Okay. Let me increase it. So far we have discussed root user. So this is the admin user. Let's call it one. That's call it. They call it as a single mode user, single root user. So by default, we got something called Ubuntu user, secondary user, and we have something called Dattu, my name. So in Windows, you have some name. In Windows, you have two users. So one is called administrator, and second is non-administrator, like the regular users. So in Linux, it works in a different way. You will have only one admin user. The rest of the people, they will do elevate their access. So whenever they need. So that elevation is called sudo. Okay. Uh, yeah. So we will see how to create a user and how to create a group. Okay. So here we are. So let me switch to root. So sudo plus su. So now I'm in root mode. I'll be switching the, no, yeah. So we have two utilities. So one is called user add, and another is add user. So in order to elevate the access, you need to have group something called sudo, or some people they call it as a V. Okay. So if some people are part of the sudo group, so they are the admins. So right now, these two are part of the sudo group. That's why we are able to perform the administrator related task. Okay. So for every user, you have a property. Okay. So the properties are called username, home directory. So you have a shell to initialize the shell, a shell session. Usually it will be bin bash. And the home directory would be, usually it looks like this, home/username. Okay. So that would be here. Like if you see this one, yeah, it's under home/Dattu. So you have few more properties. So that is password and groups. We have primary group and additional group. Okay. I think that's for now. Okay. So let's go ahead and try both. So add user. Hmm, cannot use Linux. So what is the user? Okay. User one. Right. So when I'm trying to add using the add user command, so what it's doing, it's creating a user. It's creating something called group as well. Okay. And also it's creating something called UIDs and GIDs. And you have something called home directory and some basic files, whatever it needed, basic files it's copying. So I'll keep password as user 123. Okay. User at the rate 123. Okay, I can give full details. Yeah. So user one has been created. There is extra groups, users. There is a regular group called users. It created. Okay. And if you see, you have something called UID and GIDs. Okay. So that is a important one. So whatever the user you have created, so every user you'll get a user ID. Something like, okay, let's say you have a student registration, right? So every student will have a roll number. So similarly, for every user, you have something called UID, and every user by default will get a group. Okay. So if not, we will create some group called users group, the basic group. Okay. So what do we want? We want to see what is the UID of the people. Okay. So let me go and check. Okay. As I told, root is a single user. So for the same reason, the root user will have UID as one all the time. So sorry, it's ID. So yeah, the root has there is no IDs and it's given as a zero. Okay. So okay, Ubuntu user not there. Yeah. See, this is my so yeah, this is my user. This is Dattu. Okay. So let's see. It's my bad. There is no Ubuntu user. It's only my user. And where we can see existing users and all. So we can see here. So before that, so my user got 1000. So that's the UID, and GID is also 1000. So it's showing rest of the groups. So you have sudo group that is 27. Okay. So my user got 1001 as the UID. So the next people and all, they will keep continuing this roll number, right? So that would be 1001 and 1002. So I created user one, and if I create a user two, they will get this ID. So yeah, we don't have user two. So that is it. So every user will get a UID. It's something like a roll number kind of thing. And system identifies the user using the UIDs. It doesn't consider the label. Okay, what is the username and all. So the whole Linux, it works based on this UID property. Okay. So why do we need this UID? What we are looking at the data, right? Okay. So before going here, so let's read about sudos. Okay. So we have something called sudo group, etc. Sudo. So yeah, if you see this file, right? So the root saying it has all the privileges. All the members of admin group may gain root privileges. So if you want someone to get all the privileges, they can be part of admin group. And yeah, you have a part of sudo group, so that you will get all the additional commands and you can execute any command. Okay. So we will add our user one to the admin group. So it would be user mod AG. The group name is admin and user one. Okay. The group not doesn't exist. Okay. In that case, I'll go for sudo. Yeah. So whoever I want as someone as an administrator, so they can be part of sudo. So once they are part of sudo, they can execute any command. Okay. So let's see. User one, user at the rate 123. Yeah. So how will I know this guy can perform admin task? So yeah, here it's saying, right, to run as admin root, run as the command as sudo. Okay. So sudo apt update. So now this guy, the user one, since he is a part of admin group, so he can perform the system operations. Right now he is updating the packages using apt update. Okay. So that's about the admin. And this admin is called sudo group. And does it change all the time? No, it would mostly it depends. Like in Ubuntu, you will have sudo. In something like Red Hat Linux and the CentOS, you will see it something called as wheel group. So what we are looking for here, the next part would be, yeah. So we seen this command, we seen the ID command. So we need to see these two commands and also how to create a group, right? So, so we have something called as user add. So this is a simple command. It won't give you any prompts or anything. So let's see if it is working properly. Yeah. So that's what happened. So I created a user two with this command. So what I'm supposed to do, I'm supposed to provide a home directory. I'm supposed to provide a shell, what it's going to use. Since I didn't give anything, it didn't create any home directory. Okay. And also it didn't create a shell. So do we use this users anytime? Yes. So some of the users, so we call it as system users or system accounts. Okay. So we use them from time to time for our some of the installations. Okay. Let's say you are using MySQL or something like Postgres, right? So they need users to be created, but they don't need logging. So they just need some system accounts to be created so that these programs can access. Okay. So what we do is every time we create, sometimes we'll create a user for this one, MySQL. Okay. So we'll assign the user only for this program can access, and we don't give any login permission. So as in, we won't give the shell process, we won't assign the shell session, and we don't assign the home directory, and we don't need to assign the password as well. Okay, so that is the case. It happened here, and I'll exit back. So came back here. So I'll do add group. Yeah. So I created one group demo. So now it started. The GID is also it's the same thing. So 10010203. So that's the order it's following. Okay. What we seen? Who are my ID and groups? So this is how like now I created a group called demo, right? So if I want to add some user to demo, okay, or if I want to change some permissions for this user, so I need to use a command called user mod. Okay. So you have add user and use user add. You have something called user mod. So in the user mod, you can change the groups or you can change however you want the things. Okay. So user mod. So this is how you can specify. So you can specify the groups -G. You can specify the shell, and also you can specify the home directory. So this is how. So what will I do? User mod -D/home/user2. Okay. And shell would be -S. Okay. So I'll try to SU for user2. Yeah. Okay. I think I need to create this one and assign this. Okay. But this is how we'll use this. And also we can change the user group for it. Okay. So -AG. Which group we want to add. So we want to add it to demo group. And what is our username? Our username is user2. So yeah, how we can see what are all this user is part of. So that would be groups user2 and group user1. So yeah, this is how we can see. Like if any user is part of any groups, right? So we can list out the groups using this group command. Yeah, that's about sudo, and the sudo file, right? We will rediscuss again in advance. So what and all changes we need to do there. So why do we are using it? Let's say we can create a new group and we can update the sudo. And sometimes people create sudo or groups as well. So to perform additional tasks. Yeah, who am I, right? Okay. So WHO, who, it will show what are all people got logged in. Okay. So you have 3 sessions here, and you have one login screen that is from your Ubuntu. And there is a TTY session, the time to live session as in the connection here. That's what it's saying. So here we can, this is the administration panel. Like we can see who are all people got logged in. And if we want to know which user this session is, who am I? So this will show root. So I'll go to Dattu. So SU is in, it will switch the user. Okay, that's the command. So here also, who am I? So it will show that. So let's say if I want to change the password of some particular user, so what can I do? Or if I want to delete some user, right? So, okay, sudo user del or del user 2. So yeah, it's added a cron tab entry that also it's cleaning up. Cron tab for this user that also it's cleaning up and it's deleted the user. So using user del or del user, we can delete the user. And there is a del group as well. Okay. Yeah, it deleted a group called demo. First, it will check if the group is part of any existing users and all. So see if it is not there, so it will delete it directly. So we want to see the password, right? Okay. So if we want to assign some password to any user, so we'll use this command called passwd. Um, and if you want to specify the username, this is the place. So user one. If we do it like this, it won't ask any existing password. Is it like, okay, you're an administrator for your users, you are updating the password. Okay. This is how it is. Okay. Let's say if I switch to user one. Now, if I want to change my password, so it will ask for your current password and then you can change it. So if you forgot the password, you need to ask the sudo user or the root user to handle this. So this is about the user management. Um, I guess that's up to the basic level. So any questions here, guys, before moving to process management that we're gonna go in depth? But yeah, any questions here?
Yes, Sasi. What is the uses of groups?
Okay, uses of groups, right? So that is called RBAC they call. So let's say in Linux, you have QA group, you have knock group, as in the support team, you have the administrator, you have the ops. So these are all one groups, right? Okay. Sometimes what happens is you need to provide only read-only group. Okay, so they should be able to log in. Okay, but they cannot perform any functions. Okay, only login they can do. They can check the read the files. Okay, so it's not just the sudo function. There is like multiple things they need to do. So part of sudo. And what happens is some of the many of the tools in Linux, they do depend on the pseudo groups, which groups they are part of. Okay. So depending on the pseudo groups, we can give permissions to like particular user, which are all the programs they can access. Okay. So let's say the QA team, they cannot shut down the VM. They cannot be part of the admin group. So what will we do? We will create a pseudo groups. Instead of pseudo user, we'll specify a pseudo groups and we will add these things as part of them. Okay. So let's say we have a QA user. We'll create this one as a group. So here we'll specify read only log files. Okay. And support team, we can mention that, okay, only restart the services, but don't restart a VM. Okay. And ops team will also specify, you can install the programs. Okay. And do a restart that and all. Okay. Or can you kill a process? Right. So you have a number of operations. So you can customize with these groups. Okay. So like based on the person, you can manage this group permissions. And it seems like sometimes the QA team, the developments, they want to access the system, they want to see the system, what exactly is happening. So we cannot give them full level permissions in the production. So that's the time we will give some temporary, like the read only access and all. So we will add them to part of this read only group or somewhere, or the support group, so that they can do the functionality and they can close it. So yeah, it's like we can specify, okay, this is the group level permissions, we can specify. That's the use of the group. Yeah. Does that answer your query, man?
Yeah.
Yeah. Okay. So yeah, I'll ask again. So before jumping into process management, any questions, guys?
So see, is admin and sudo are same or different?
Sudo is a escalation, man. It's a process of escalation. It's like, okay, how to tell you? Okay, you have an ID card. Okay, in your ID card, you have some additional tag with you. Okay, so you have given additional ID card. So you have a regular ID card where you can go enter the building. Okay, so if you want to access specific floor, you need to have a additional ID card, or your ID card needs to have additional permissions, right? So when you are entering that group, you need to swipe your ID card. So it will determine that, okay, this guy has a additional sudo access, so he can enter this room. So similarly, the sudo is process of that additional ID card. So that you can perform the additional task. And root, as I told, root is the master user. So we won't give any access to root at all. No one will have root password. No one will access. Only sometimes what they'll do is, see, let me show you this one. So I don't know root password. So let me reset it. Passwd. Yeah. Okay. So I have the root password. I'm inside the VM, as in directly in presence of the physical VM. Okay. So you connected via putty. Okay. So the question is, can you access it as a root user? Okay. So that would be like this. Yeah. Access denied. So how it is happening is, so sudo vi etc. You see, this is SSH configuration. So we're going to go SSH as well. That will also go in deep. So if you see here, yeah. So do you see this one? So this is commented. That means it's not going to work. So you have something called permit root login, prohibit password. So this is the setting. What we are mentioning is, so I have n number of users. They cannot directly log in as root. So they can do your perform like this, but no one will log in as root. So if I give permission as root, they can do anything. So that's the reason we have the groups. So we will control the access. So yeah, you cannot log. Usually, that's what happens. So no one will give you root permission. You have to log in as your user, and then you have to take the privilege escalation. So yeah, as I told, you have to show your second ID card and go and do your task as your system maintenance or reboot your VM, or if you want you shut down sometimes, right? So that whole things we can access through that. That's that okay? Is that okay, Praveen?
Yeah, Sasi, yeah, okay.
Yeah. Okay. So now we are switching to process management, man. Okay. So let's see. We are switching to the, let's say, what to say. We are going to the basics, the roots. So this is okay. I'll download one package. Okay, something like MySQL download. This is the downloads. Yeah. Do you see this one? x86 64 and ARM 64, right? Yeah. Any Mac users are here, man? Anyone who are Mac using Mac or someone? Yeah. Just a minute, guys. So yeah, if we see here, even Linux, you have Windows, right? So if you see here, we have two different architecture. Okay, one is x86 as in 32 and 64-bit, and you have ARM processors. Okay, like ARM architecture. So what exactly it is? Okay, just a second. Okay, I had to text someone. So yeah, as I told, we are seeing two different architectures. So one is x86 and ARM 64. So yeah, we're gonna go check what exactly it is. Okay. So what happens is what exactly your CPU does. You have a CPU in your you have a CPU in your computer. So what exactly your CPU does is so you have a clock cycle. Okay. So you have a clock cycle. So this CPU is 32-bit and you have version as 64-bit and all. So the overall we call it as x66. So that's the notation from the processor instruction. So we have something called complex instruction set. So that is where you have a multiple number of instructions for CPU to execute. Okay. So what happens is, okay, let's say I'm opening a Chrome tab. It's a process, right? So it's gonna get divided into multiple threads, multiple mini processors. Yeah, Shankar, you have any question? Okay. So multiple mini process or let's say multiple mini requests to process. So every cycle, every CPU has something called instruction set. So what is this instruction set is? So the CPU would want to interact with your hardware, right? All the USB devices, the monitor, the RAM, GPU, and all other things. So this instruction set will specify, okay, how will I communicate, how my CPU should communicate with the hardware. So this will keep on running. But the x86 has a complex instruction set. Like at one cycle, it has like multiple instructions and all. Whereas the ARM has a reduced instruction set. So what happened is earlier the people are using x86 and all. all the x86 process, whatever you read in your college and all the things are pointing to x86. So you're seeing, right? Intel i3, i7, i9. So or ARM processors, right? I think you have Apple Silicon. Okay. Uh, example of Yeah, you have Snapdragon. Yeah, I forward. So and also your mobile, right? Okay, your mobile processors actually this one Snapdragon. So all these things they do work on ARM. So why people introduce this ARM is so what they thought. Okay, whatever the current CPUs are there, the x86 and all. So they are consuming most energy and the size is very big. Okay. So instead of that, they thought, okay, let's introduce a new one where you will have in the instruction set is very less compared to the earlier one. So this is called CISC and this is called RISC. So since the instruction set, the instructions to execute per clock cycle, since those are very less, let's say here if it is 10, let's assume this is 5. Okay. So what is the additional advantage we will get is, so we'll get the energy efficiency as in the electricity, the power consumption, whatever this processor is doing, that would be very less compared to the traditional CPUs. And also this executes, as I told, this executes multiple instructions per clock cycle. This executes single instruction. So this is performance oriented. So this is the processor which in general we are using for highest performance and all. Okay, so sorry, this is AMD, Intel. Okay, and why the size part came in. So we'll explain that. So this is the reason all the mobiles and all we are using the ARM process. So how ARM works is there is a company forgot yeah there is a company for ARM. So that company gives the schema as in the let's say something called design document. Okay, so yeah, ARM Holdings it is. So the ARM title is Advanced Risk Missions. So you have a ARM company. So where they will design, where they will give you the design document. So what they'll tell is they will sell this design document to the companies. So companies can go and manufacture their process. As in, so you have a Apple now. It's Apple is designing their own processors. You have a Snapdragon for all the mobiles. We are using this Snapdragon process or the Qualcomm, right? So we are using this one, the ARM process, and also the size is very less since the instruction set is less. The ARM process size is very less. So that is the reason it is able to fit inside our mobiles. Okay. And you have something called single on chip system. So I'll tell you what it is. So that's about a baseline of the platform. So you even have a Raspberry Pi, right? Okay. So you have a Raspberry Pi. This is the smallest hardware you can find. So this also is working on ARM. So earlier the x86 process were giving highest performance and all. Now the ARM process got catch up to the speed. So they are also giving the full level performance. Okay. Uh, yeah, this is the document as I told. So yeah, So yeah, this is the CPU structure as I told. So in x86, what happens is you have a CPU at your onboard, okay, and you have a RAM, additional RAM. You have a cache, I think it will come combination with your CPU. Okay. And you have additional GPU and you have all the rest of the hardware. Okay. Whereas in coming to ARM, you won't get any RAM and all. Everything will get combined here. Okay. The CPU L2, GPU RAM, right? So everything will be combined in a single chip. So even the RAM also, it will come combination with your CPU. So everything will come as a single chip, even the GPU as well. Okay. So let me see. Yeah. So if you see, right, what they're saying is, so unfortunately, the upgrading the RAM on most Android phones is not possible. So unlike computers, most smartphone will come with the fixed RAM soldered to the main circuit board. So this is what I told. So you have a RAM in your mobile, whatever you're using, but the RAM is completely merged with the CPU. So if your RAM is gone, you need to replace whole CPU, man. Okay, there is no other way. You have a Mac systems, right? Okay. Yeah, it's the same thing. Even for the RAM also, you cannot upgrade the yeah, this is what you're saying. You cannot change the RAM in your MacBook Pros. So whatever is coming with your system, that stays as it is. So in case you want to increase the RAM, you need to throw it off the chip or you need to throw it off your laptop, right? You need to buy a new one. So that's how it is. Uh, the additional advantage in Intel is, so if your RAM is gone or if you want to increase your RAM, you can use it. So that is called extendable or customization. Okay, let's call it. So here we don't get that customization because everything will come soldered to your single processor. So that's about it. Before going to these threads, right? Any question here? Is this topic clear or you have any question? Yes. Yeah, I hope. Okay. So let me move forward then. So cores, right? The CPU cores. So in earlier technology, so we have a single core CPU. So as in everything works as a single core. That means you can run only one process here. Okay. So what do you mean by one process? I'll come there. Okay. So later point of time, we were able to combine. Okay. You have this one as a core one. So this is core 1, core 2, core 3, core 4. So this is called quad core computer, quad core processor. So as we see nowadays, everyone has like 16, like whatever the VMs you are spinning up that has 16 cores and all, or whatever the process they are coming, they're having 8 cores and all. Okay. And one more thing, the ARM, right? I think even AWS is also providing ARM systems. Okay. Yeah, this is the one, Graviton processor. So earlier they were giving x86. Now AWS is also providing this Graviton processor. So this also works in ARM. So that depends on your customer requirement and all. Okay, what if some customer told like I want to run only on ARM? So that's where we'll go here. Yeah, coming here, as I told, like we have multiple cores, so 4 cores and all. And what the core says is, so each core can execute only one process. So that means you have only 4 processes that can run. Process not in the task manager, whatever we are seeing. Processes as in the set of instructions as in mini processes. Okay. So we can run only 4 processes at a single time in the quad core. So what happened is after that, they bought a concept called threads. So each core has the 2 threads here. Okay. So one thread can handle multiple one process. So now we can set. Yeah. we can set 8 process for all this 4 core 8 thread CPU. So we can run 8 process in parallel. Okay. So let's go and check the task manager. Yeah, you have the, sorry. So if you see here, right, you have the process, you have the base speed, the CPU cycle speed. Okay. And do you see the processes, right? You have the threads as in 4 to 5 8 threads. So that many threads are there which are spinned up and which they are trying to process. So, and what we did, one of the CPU cores, so we assigned to our Ubuntu VM. Okay. So we have 4 cores. So we donated 2 cores, or we assigned 2 cores from ours to the Ubuntu VM. And this is where you can see the threads, like threads handles and all. Okay. So we can go in deep, but I think this should be fine for now. And we will see how exactly the CPU and RAM things works. Okay. So now when you spin up a process, as I told, so when you spin up a process, so when you spin up a process, one single process, it will open multiple threads. So let's say it open 1,000 mini process. Okay. We call it, let's call it CPU process. Okay. So let's say I opened a Zoom meeting now. Okay. And also I opened VMware. Right? So this whole thing combined, let's assume we'll get 1 million requests. Okay. But what we did is our CPU can handle only 8 process threads. Okay. 8 CPU threads, 8 CPU process. So what exactly happens is whole 1 million. So it will maintain in the threads. So it will go into a queue. Okay. So the opening cron time, this is a queue. So all the 1 million minute requests, they will be able to execute in a millisecond actually. So in millisecond, it will perform 1,000 operations. So it will do in a queue process. Okay. You have a queue, right? So let's say you have 1,000 operations. Yeah, you have a 10,000 operations. So it will keep on executing 8 process at a time. Okay. So this cycle I did 8. So next cycle I'll do 16. Next cycle I'll do 24 and all. This cycle as in a mini, let's say in a millisecond format. So it will be able to execute the thousands of the commands basically. So that's how the CPU works. So that's how the cores are also dependent here. And we will move to RAM. As I told, I'm covering at a basic level, not in depth, so that you will get understand, okay, how the CPU is working. Yeah. Any question, guys, here? Okay. Since there are no questions here, so we'll move to the next one. So one important parameter, even when you're buying mobile, you will see this. Okay, I have a CPU of Snapdragon. This is the CPU. This is the model number. It has this much frequency. You have this much thread, CPU threads and all, right? Or CPU cores. You'll see. You have a GPU as well. Let's not bring that into picture. It's more of video processing. Okay. So now what happening is, so when you are opening a process, right? So all the process will store all the process related the program, right? So it will get stored in the hard disk. So that's where your program is stored usually. So what happens when you execute a program? Let's say you opened a something like a notepad. Okay, let's take it as a notepad. So the notepad program usually exists in the hard disk. So when you open it, the notepad program will get copied to RAM. So RAM is very fast. So the now the RAM handles the notepad program. Okay. And RAM is volatile, as you all know. So if the power is lost, the RAM whole data will get lost here. So yeah, the RAM is open the notebook, the notepad, and it will keep it in its thread. So when you're writing the data, so everything as I told, so this will go to the CPU. All the data, the notepad data, it will go to CPU. So whenever you are writing, the CPU will say like, okay, write these functions to the notepad. So it will get stored in RAM. Unless you go and write it, so it will go stored in the hard disk. So this is how it happens. Even you open a game, a MS Office or something like an Office utility, this is how it goes. So first of all, it will run in your, open from your hard disk. All the data will get copied to all the required data basically. So will get copied to your RAM and then it will get processed. So to further processing, we'll hand over to CPU. So you have read write over the RAM. So what happens is, so only the first time the data opens from your hard disk. So from the second time onwards, all the data will get read from your RAM itself. Okay. So think, yeah, I cannot send it back. It's okay. So all the data from next time onwards, CPU will process only from RAM. It will say like, hey, you already have the data, so let's go read it from your storage, but let's not go to the hard disk every time. Because going to hard disk is an expensive thing. Like the read and write of the hard disks are very slow. I'll tell you why. That is the reason all the transactions mostly happens between RAM and CPU. And that is the reason as fast as your RAM is, that's how your performance will be really good. So that's the comparison between 4 GB RAM and 6 GB RAM, right? You have 4 GB, 6 GB. So what exactly happening here? Let's say 4 GB RAM can perform some 5 million operations per second. Let's take it as an example. Whereas 6 GB can perform somewhere around 8 million processes per CPU cycle. Let's say clock cycle. So yeah, that's how it is. So that's how the performance of the RAM comes in. That's why people say like, hey, take a big RAM. Let's not go for a smallest one. Let's go for a big RAM. You can. So your performance will be really good. I think we are running out of time. That's okay. So yeah, that's the basic here. And coming to hard disk, we have two different hard disks. So the magnetic hard disk and the solid state hard disk. So what happens? So this is how your magnetic disk is. So every data needs to be written this magnetic disk. So this using this head. So let's say if I written one bit here, if I need to write next one, so the disk needs to be spinned up. Again, it will write it here. So like that, the read and write speeds are comparatively less compared to SSDs. So earlier days, we only have this magnetic hard disk. So we have SATA and we have the old type. Still, it's a still slowest hard disk, I can say. So later we got something called solid state hard disk. So that would be looking like this. Yeah. So you this is the solid state hard disk. Everything is a semiconductor. So you can access the data however speed you want, however you want, and all. So that's the reason the solid state will work very really fast. And when you are spinning up a VM in AWS, you'll have an option whether it is a magnetic or solid state hard disk. Depends based on that, you will get your overall performance. So as I told, three different things are there. What is your CPU cores and all? What is the RAM you are exactly using, and what is the hard disk? So not only in a Linux server, even your regular PCs. So your performance really based on these three factors. Okay. I'll take 5 more minutes to explain swap. Okay. So, so what happens is Yeah. So what happens is RAM needs additional space. Let's say you have RAM only can handle 4 GB of data. The rest of the data, let's say if it is needs to open the rest of the data, it needs to get copied from hard disk. Instead of that, so we will convert some amount of hard disk here as a swap. Okay. So that it's called as virtual RAM. So that whenever the RAM needs data, so it will get copied from the virtual RAM. So in Linux, let's say if you in a server, right? Okay, you have multiple process running and all. You want to increase the performance, so you can use this swap process. As in, you can enable the swap so that some of the hard disk space. Let's say you have 1 TB hard disk. Okay, so your RAM is around 8 GB, so you can assign 16 GB to swap file. So you'll get swap file created. Yeah. This is about it. It's more of hardware, but once you know about it, like when you going forward, right? So how when you are troubleshooting, you need to know these basics. Okay, what exactly is happening? What kind of hard disk and what are the hardware it's currently running on? So sometimes the request comes in, increase the hardware. So that's where you need to consider all these things. Okay. So yeah, any questions here, man? Yeah, we don't have Praveen here, but it's okay.
No, no questions, I say for me.
Okay, so I'll show you three different commands. So for the process management. Okay. Yeah, so you have a top. So as I mentioned, top will show all your the top will show all the current CPU stacks, as in CPU, what is the RAM. So if you see here, right, it's showing percentage CPUs, but we won't get to know cores. Okay, so I'm pressing one. Yeah, as I told, we assign three cores here. Okay. So CPU 1 core, 2 core, 3 cores. So all the process, they will get distributed across these cores. So we will see right now its overall utilization is somewhere very less. We are not stressing the VM basically. Yeah, we are not stressing the VM. And even the RAM, as I told, we assigned somewhere, we assigned 6 GB, 5.5 GB RAM, and yeah, I don't think we didn't enable the swap. That's why we are not seeing it. Okay, so these are the, if I press one, you will get this data, and one more is so you have the load average. It will show how many processes are being executed, like the number of processes are being executed. So it will show overall CPU load, not overall CPU load, as in overall system load. That's what it will show in the load average. Okay. It will show the number of users got logged in, and this is the uptime. How much time it's been, the system has been up and running. So that data will get here. Okay. So we'll see. Yeah. So we have one more. One more is somewhere around which process I can take. I can take somewhere around RDD or something. So PS-EF, it will show current execution thing. Okay. So let me show you this. Yeah. So I'm seeing the execution, the state of SSH, right? So PS command, it will show what exactly is the utilization at that particular time. So like if I want to see it for SSH, I can use it as the grep command. And I this is the PIDs. Okay. So let's say if I want to end the session of this guy, so sudo kill -9 and we'll give this PID 3299. So there is a place where some of the time some process is running for a very long time or taking huge resources. So upon the confirmation, we'll go ahead and clean it up. So as in we go ahead and kill the process. So that's about it. You have something called as free hyphen m. So this is what it will show. As I told, it will show your RAM. What is your current RAM and how much is the available thing. So the rest of the things it is using as a cache, but usually this is the available RAM, which is currently for use. And as I told, swap is not enabled. We can see how we can enable the swap later. Uh, yeah, we can go deep further for the disk partitioning and all in a different session. But most of the process management runs around these tools. Okay. Sorry, the top command and PS commands and these three commands mostly. So that will give you the required stats. So yeah, any question, guys, till here? Like I'm concluding the session here. Any question, guys?
So do we remember all these comments? Like
That's a good
there are so
question.
many comments.
No, we like three commands, right? Right now, till yeah, we had a user command, and this is top. We have the df hyphen h. You have the free hyphen m, right? See, let me tell you one simple thing. So you have the task manager, right? So you have all these options. I get to know, okay, since I open multiple times, I know, okay, where and all which option is there. So similarly, for Linux also, if you're doing regularly day-to-day basis, so you'll get it in the flow. So I suggest don't remember it. I suggest do practice it more. So you will get once you do hands-on, right? So I practiced it for like many years and all, like as part of my day-to-day thing. So I practiced it. So that's why I remember the commands. Yeah, ultimately you need to remember the commands. Otherwise, just make a notes for now. Okay, this command is for this particular purpose. This is where I need to use this one and all. So yeah.
Yeah. Okay.
Yeah. Any questions? Any other questions, guys? Venu, Rahul.
Yes, I see. So now when we are troubleshooting, if there is some issue or some issues might be occur in the hardware level, and there is a situation like we need to troubleshoot at the hardware level. So what are the basic logs, whether it might be related to the storage or processor or RAM. So what are the basic logs that we need to go through while the troubleshooting at the hardware level? Are there any
Okay,
logs that we have?
okay, you are combining two different things. Okay,
Mm-hmm.
so application will produce log. So you have
Yeah,
some logs. Okay.
yeah.
Uh,
So those are the application logs.
yeah, you have application logs and you
Mm-hmm.
have system logs.
Yeah, system logs. Okay.
So what happens is like the system logs will show what exactly is happening. Is it able to being right or is it waiting for some process
Mm-hmm.
or the memory is not available? If the developer adds that particular log related command, the system logs will show what exactly you're looking for.
Okay.
Otherwise, it will not show anything related to these one, the CPU, RAM, and all. So
Okay.
if your developer mentions all these things, okay, if there is RAM not memory is not available, so it
Mm-hmm.
will write it to the system log. I don't have memory available. That's the reason I cannot initialize. So that's
Okay.
about it. Otherwise, you need to use the same commands. You have the top, you have the free hyphen m, right?
Yeah.
Okay. Or with the top command, you can check how much is the memory it's trying to utilize. Okay.
Mm-hmm.
Or the
Mm-hmm.
system CTL, like whether this
Oh,
particular process is spinned up or not. Okay.
okay.
So all the thing you can use it here, PSIF new. So mostly
Okay.
these are the commands. You have the disk space as well. As I told, this one we will take in a different session. How to handle the disk space, disk utilization, and disk file
Okay.
system. Okay.
Okay. Okay.
Yeah. Any other question, guys? Okay. I'll consider it as no. Yeah, we can conclude for the day. Yeah, I'm trying to do a calendar thing. Okay, so you will have a yeah, I am trying to spin up a calendar kind of thing. So I can add your email IDs and send out an invite. So you'll get it as every day. And this Holi, let me check. Like I'll put a vote if people are little free. Did they have the week off or somewhere? Or Saturday, I will try to set up a session around 10 a.m. So who are the people who cannot attend? They can come and ask any random questions. So I want to set it up as a Q&A. Yeah, let's see, guys. Okay. So whatever the email IDs I have, I'll try to send out an invitation. So I'll keep the mostly this link as a recurring one. But yeah, let's see. And
Yeah,
yeah, if
actually,
you
actually, I think I had like I wanted to do this for myself to add this event daily in my calendar. I think it by mistake went to everyone. I'm not sure.
no, I didn't got that. But yeah, let's see. I'll submit a new one, man. That's okay. I'll send a new one.
Yeah, I think
Uh,
people accepted that invite, so that's why I got some mails now.
Oh, okay. Yeah, we'll see. I'll send out a new one. That's okay.
Yeah.
One other thing is, yeah, you know any people who are looking to learn from scratch or someone? I know we are in the beginning phase, so it will take some more days or some more sessions. Once we cover the basics, we'll go in a full-fledged manner. Like we will spin up, as in we will go with the CI/CDs, we'll go with the shell scripting, we'll go spinning up the web applications, all these things. So yeah, before that, it's better. I thought, okay, you know the Linux basics from end to end and all. Yeah, if you any of your people, friends, or someone they are looking for learning cycle where exactly and all or where to start, so you suggest the channel or suggest the calendar, whatever is comfortable. So if they cannot attend, you can go for the recordings. So yeah, that's what I thought to tell you. So yeah, I guess we are good for the day. Any questions, guys? Okay. Yeah, thank you everyone, thanks for joining. Have a good day, guys.
Thank you.
Thanks, Jesse.
Yeah.